Now, using the concepts and the information we've learned in this section, let's go through and solve this problem. There's some things that aren't on the, you might see in your packet, that I put in here that make this have more sense. It may not be drawn to scale, so forth and so on, but CD is equal to BA. Okay, the measure CD equals BA, which equals 24, and the measure of CY equals 45. Now, using the concepts that we've known, if those two chords are equal to each other, we know that what? This has to equal that. Okay? I don't think we need to know that, but it has to equal that. We also know that since this is perpendicular, this equals this. Great. Well, if CD equals BA, then that means this is equal to that, doesn't it? Well, it not only, if it's perpendicular to that chord, it not only bisects the chord, it bisects its arc. So we know that is equal to that. Well, and because these two are equidistant, we now know that this is going to be equal to that. Okay? And if we really want to get down to it, tunk, 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 2, 3, 4. So those are all the kinds of things that we know simply because of the information we've been given. Okay, now let's go over here and see if we can find certain things and go from there. Let's start over here. We know that BA equals 24. Well, PX cuts that sucker in half, doesn't it? Because that's perpendicular. So how long is AQ going to be? Half of that, 24 divided by 2 equals 12. Well, how long is RC going to be? Well, we just did that calculations. We said they are equal. So that's going to be 12. How about QB? Well, it's the same as QA, isn't it? That's going to be equal to 12. Well, how about AB? The whole thing. We're already told that it's going to be 24. All right? Now then, the arc DY. DY has to be equal to CY, which is going to be 45. How about the arc AB? The whole thing. Well, let me see. CY is 45. This is 45. 45 plus 45 is 90. We know that those two equal each other. Therefore, that whole thing has to equal each other. And so we would have a 90 degrees there. Okay? I'll let you figure out the other three by yourself. All right? So just simply by knowing some things about what's going on there, we can find out all kinds of things. And determine lengths and distances and measurements. Well, let's do another sample. I think you'll recognize this from your packet. This one's a little bit more involved. We're given a circle. I think this is the diagram we have. And DG, we're given that DG, what all do we know? Segment DG is congruent to segment GU. Well, then that means we know this is 3. Okay? All right? Now, what else can we know from what we're given? Well, this is a right triangle. It's a 3. The hypotenuse is 5. How do we find that? We can just simply come back and, well, we're going to have to find that right there on that one, aren't we? So we're just simply, let's just go on that and play with that. So in order to find this, we need a squared plus b squared equals c squared. Well, a squared is 3 squared plus b squared, we don't know the other side, equals 5 squared. So 9 plus b squared equals 25. Subtract that, b squared equals 16. So b equals square root of 16. b equals 4. So this right here is going to be 4. Okay? Well, what's TR? If this is 4, we know because this cuts this at a perpendicular, it bisects that, so that's also 4. We add those together, we're going to have 8 there, aren't Okay? All right? All right, and we're looking at what is the arc of this right here. So we're looking at this right here. Well, that arc is going to be the same as this angle right here, isn't it? So if we set up a trigonometric ratio, can we find that angle? Yeah, because we've got a right angle right here. If we're standing right here, opposite over hypotenuse, we can sit there and go like, wow, that's a so. So katoa, opposite over hypotenuse. So we're looking at sine of x equals 4 over 5. Okay, so that's sine -1 of 4 over 5 equals x. Okay, so let's find out what that is. 4 over 5. Whoops. So this x equals, from what I've got, is 53.13. Okay, 53.13. So if that is that, then this central angle is that arc, right? So this arc is going to be 53.13. Okay? Well, what's CD? If we know if these are the same distance, then these are going to be congruent. So these babies have to be congruent, right? Well, that means this is 4. So CD is going to be 4. Okay, well, what's GD? Well, we know, we're told that they're equal to each other, so DG, okay, we're told what that is, aren't we? Yeah, let's make sure. GD is 3. And what's arc AB? Well, let me see. Arc AB is this. What do we know about the radius? The radius has to be 5. What's this going to be? A 3. This is going to be 4. Wow, this angle is going to equal that angle. So what's this arc here? That arc is going to be the measure of its central angle. Its central angle is 53.13. Now, one of the things that may be really strange and weird to you is that we're looking at a right triangle and solving what an arc is from it. Why? Because we know that the central angle here, this central angle right here, BGA, okay? If we know that angle, we know that that is the measure of, degree measure of this arc. How can we find it? We can find it by using that right triangle. Okay? And using our trigonometric ratios to find that. Alright? So essentially we had to go through chapter 8 before we could get into here and do this, because you had to know what trig was in order to do and solve these problems. Triangles and circles, they just go together. You got angles, you've got arcs, ways to calculate things, your trigonometric ratios. You'll see some of those in the practice that you have. Do that. If you have questions, please come ask and go back to this. Arcs and chords and problems involving them.